In this video, we're going to take a closer look at correlation. In other words, what does that R tell us in linear regression? So first of all, recall that linear regression can be any number between 1 and -1. Notice right here my R value is 1. That means basically every point's right on the line. If I made the line less steep, but still all the points were in a row, notice it's still really close to 1. Let me see if I can actually make it perfect correlation. We'll see if I can do it. Yep, there's a perfect correlation of 1. Notice, regardless of the slope, if it's a perfect line, the slope, the R is 1. Now, if the line is negative, I want to make that a little more perfect. If the points are going in a negative direction, then the R is -1. So R doesn't tell us slope, it just tells me how closely the points fit the line and which direction the line is going. So it tells the strength and direction of a linear relationship between two variables. Now, of course, correlation isn't always that perfect, so maybe we have a few points scattered like this. Okay, so what kind of correlation would that have? How strong would that be? Notice there's a correlation of 0.69, so it shows there's some scatter. There's still the line is still going in the positive direction, so R is positive, but the correlation isn't as strong. Now let's make one that's a little stronger. Okay. So here we have a correlation of 0.95. What happens if I add an outlier, some point that's really far away from the line? Notice how much difference it made. It went from 0.95 to 0.44 with just 1 point added. Similarly, if I have kind of a weak correlation like this, and I add just a couple points, more points like here, notice how much the correlation strengthens by adding some points to make it appear, the data appear more linear. And then let's look at something that has a correlation that's very weak. So if we put data values just all over the place with no particular linear trend at all, notice that our correlation is nearly 0 here. But I want to introduce you also to the fact that you can have a strong linear correlation. 0.96 is very strong, very close to 1, and yet the data is clearly not linear. So just having a strong correlation doesn't mean a line is the best representation for the data. Similarly, I can have something that has no correlation at all, nearly 0, and yet there is a relationship between the two variables. It's just not linear, it's quadratic. So the fact that there's no correlation doesn't mean that there's no association between the variables. It just means there's no linear association between two variables. Now we're going to see some regressions on our calculator that have an R value that aren't linear. So in our next video, we're going to talk about the linearizing nonlinear equations. Video is going to talk about why it is that we get an R value for some functions that aren't linear.